Okay, hello guys. Today we are talking about the indefinite integration. Okay, that's the first part of how to calculate the integrations. Okay, so here you can find that we have the function y equals to x squared plus 3 and y equals to x squared minus 1, right? And we can say if we want to differentiate it, okay, so we can say x squared plus 3, that differentiation dy over dx is 2x, right? And here the differentiation dy over dx is also 2x, right? So we can find that the differentiation function 2x have the same original function that is x squared plus 3 and x squared minus 1, right? Okay, so then we can say, oh, maybe here they have the same gradient of them, right? Okay, so here is a graph of the function. So you can find here in this page, we have the x squared equals plus 3 and x squared minus 1. So we can also say that here if we have a function that zero differentiate the same when it has a different y position, right? Because the functions or the graphs are parallel with each other, they have the same shape, so differentiation must also be the same, right? So we can call this function as a family of the functions, okay, that they have the same gradient and the gradient always equals to 2x, okay? So, okay, so sorry for that because it's dark right now, okay? So let me log in again. Okay, here it is. Okay, and here is about the indefinite integration and it's the inverse of the differentiation. Okay, so we can call here the steps when dy over dx equals to 2x because y equals to x squared plus c. So here c equals a constant. C can be chosen as 1, negative 2, 3, or any other kind of values. Okay, so we can say that the equation y equals to x squared plus c forms a family of curves. Okay, so we can all call this method or this step is called the integration that is find or in order to find the original function. Okay. So here's the exercise for you. So if we here we have dy over dx is 6x squared, so the problem is find us to find a family function. So we can say 6x squared because it's x squared. So we can say x squared comes from the x cube, right? Okay. So x squared comes from x cube. So we can say here that this is from the original function x cube, right? So we can just consider here is ax cubed. So the differentiation for this time is equals to 3 times a and then x squared, okay? It's 3ax squared, okay? That is for this kind of integration. Okay. And also we have such solutions like here we have dy over dx in 6x squared. We can say that the function is 6x cubed. But just consider if you're just trying to like dividing or differentiate the 2x cubed, for the first method is to put 3 in front of it, right? So it's 2 times 3x squared. And then we have to set that power has to also minus 1, right? So 2 times 3 and x3 minus 1. So that is the final answer for it, right? And also, the method is just inversed, or the process is inversed. So first, we have to over the new power. Okay, so that is for 6x cubed over, oh, sorry. The first step is to add the power. Like here, the final step is to minus the power, right? So here's for 6x squared plus 1, okay? That is the first step of the integration. And the second step is to divide it by the new power. So you can just consider like here, first is to times the new power, right? So it's divided the new power that is for 6x cubed over 3 plus c, okay? The final step is add c. So here is how we can understand it for integration. So first step is add 1 to the power, second step is to divide by the new power, and the third step is to add a c after that, okay? So that is it, and we can set that also we can set that is formulas for the integration. Okay, so that is for dy over dx equals 6x squared, and we can also say that the differentiation or the original function here is 2 times x cubed plus 5, okay? That is for this. And here we have the indefinite integration. So here we have dy over dx equals to 3x minus 1, right? So we can say for this step, each part of it trying to first add 1 on its power. So 3x can be considered as 3x 1 plus 1. And minus 1 can be considered as 1 minus 1 times x 0, right? X power 0 and plus 1, and then plus a c, right? And also we have to divide the new power of each term. So here is for 2, right? Because 1 plus 1 equals to 2. And here the step is to 1, right? Divided by 1. So the final answer is for 3x squared over 2 minus x plus c. That is for this problem. Okay, that is it. Okay, so here is an exercise for this. And we can set that here is the functions or the gradient here. So how we can find the value of the curve. So first step is to uh, make power added 1, like 3x cubed and plus 4x squared, right? The second step is to divide it by new powers over 3, and here's over 2 plus c. Okay, so the value here is for x cubed plus 2x squared plus c. Okay, that is it, right? And for this function, we have to first power plus 1 is x power of 3 and minus a half x power of 1 plus 1, and then plus 1 times x power of 0 minus plus 1, right? And over or divided by new power is 3, 2, and 1, right? And also we have to add a c. So finally, after these three steps, we can just trying to simplify this one third times x cubed minus 1/4 x squared plus that is for x, right? And plus c. Okay, this is for this problem. And for last problem, we can set x plus 2 times x minus 3. So first step is to just trying to expand it as x squared. Here is for minus 3x and plus 2x is minus x and then minus 6. And also for each term, first make the power plus 1, that is for x cubed, right? Second step is x squared, and that is 6x. And then divide by new power, that is 3 over 3 over 2 over 1, right? And then plus a c. So this value can be, or this formula can be written as 1/3 times x cubed minus 1 over 2 times x squared minus 6x and then plus c for our final answer, okay? But that is it. I think I can truly help you to solve or understand about the indefinite integration problems. This is very important for you, okay? So that's for this always. I'll see you next time. Bye. Okay.